Hello and welcome back. My name is Amir, and in this video I'm going to talk about the puzzle on day 15 of Advent of Code 2022. As you can see, I have already solved the puzzle. The coding part is not very hard to understand, but there is some mathematics behind this puzzle that I would like to describe that more. So let's get to the puzzle and see what we are facing today. So in this puzzle, there are a bunch of sensors and a number of beacons that are close to those sensors. So if we look at like something like this, for every sensor there is a beacon that is closest to it, like this, or for example here for this sensor we have this beacon that is closest to it. And each sensor and beacon will form a shape like this that no other beacon can exist inside or around that shape. So for example, if we have this sensor which is mapped to this beacon like this, there will be no other beacon inside this area or around the edges of this area. There might be other sensors like this, which is not very important for us, but the thing is that there is no beacon. We want to figure out for every given row like this, how many points are not available for beacons. Like for example, in this scenario, these are not available for beacons because they are already in the area for this sensor beacon pair. So for example, suppose that we have a bunch of shapes like this, and we have a line here like this, and let's say that this point is the sensor, which we call it the coordinates A and B like this. The thing that we want to find is this position and this position, and everything that is in this part or in this interval cannot contain a beacon. Okay, so there is something that is in the code here, in the puzzle here, Manhattan distance. Manhattan distance says that looking at this shape, the distance between this blue circle and all of the red circles around it are 4, because there are 4 steps going from this one to any of these. 1, 2, 3, 4. 1, 2, 3, 4. Or I don't know, like this one. 1, 2, 3, 4. So this is what we are going to use for this puzzle. So if we think this is a sensor, the beacon can live on one of these red lines, and there will be only one beacon because that's the beacon that is coupled with this sensor here. Okay, so we want to find this line. We know that this distance is d, or our distance. I mean, this plus this is d, like here. We are going from here to here. So 1, 2, 3, 4. This is always d. The same for this, the same for this. Okay? So we need this plus this is d. This point, we know the y value for this because this is lying on this line, but we need to have the x. So if this is x and y, using the Manhattan distance, I can say that the absolute value of x minus a, or a minus x, we are using the absolute value so it doesn't matter. So a minus x, or x minus a, plus y minus b is equals to our distance, right? The same is for here. So we are taking this and adding this to this, so it will be d as well. So using this, we can easily find the value of x. We would say x minus a, x minus a is d minus this absolute value, and then using the positive or negative of this, I can find two values for x, which will be these two values. So how can we find out the intervals? So for example, if I have like a bunch of these like this, and then I go and do something like this. So this is one interval and this is another interval. I need to take the union, so I will count this from to here and then make a union with this, so it will be something like this, and then I will add this to it. To make life much more easier, when I have all these coordinates or x's, then I will get the minimum and the maximum, and then loop through every position and see if they are inside an interval. If they are, I will add them, and if they are a beacon, then I will not add them. So it will be something like this. So let's go to the code and see how did I implement that. Okay, so in the part 1, I just splitted the data based on the new line, which will give me each of these lines. And then I have an array of sensors and an array for beacons. So then I will go through each line, split them by space. Then I will take different parts for x, y, and for the x, y for the sensor, and then the x and y for the beacon. And of course I will convert them to numbers so that I can work with them and then push them to the sensors and beacons. It's clear that the index 5 of sensors array will be mapped to index 5 of the beacons array. Then I'm going to find the distances, and it will be another array which the index is the same with the sensors and beacons. I'm just going through and looping through all the sensors and using the distance function that I have it here, that is this thing that we have here. I can figure out the distance for every pair of sensors and beacons, right? Then I have a constant which this can be changed, and then we can find out the number of the positions for any other line. Then I will have two other arrays. One is the intervals and one is the allowed x. For here I can find the intervals between two points of the sensors, and I will add these intervals to an interval array. It will be something like this for the intervals. And then we have the allowed x, which is the x position that is allowed, so to say, which is the beacon. So I will go through the beacons and see if the beacon is, if there is any beacon that is lying on the line. So for example, if we have a beacon here, then this is allowed. I shouldn't count this out. This is allowed because this is mapped to this sensor and it's fine. So this is where I am taking out those beacons out. Then I will find the minimum and maximum, and here I am just checking if that position is already allowed. Just I will go on, continue, otherwise I will add it to the result if this is between the left and right. And then at the end I will just log the console and everything is fine. So this was part 1. So let's go to part 2. So for part 2, they say that there is a distress beacon that is not detected by any sensor, but the distress beacon must have the value of x and y that are between these two values. So we need to find a way to isolate that distress beacon signal and then find the x and y and then do some calculation on that, like multiplying by this number and then add the y value. Like this, if for example our lonely beacon lives here, then we need to multiply this by this value and add this to it. So how did I solve this one? So I thought for some time and came to realization that the only configuration that such beacon could live is something like this. This is the only configuration that it could have a single point here that is, isolated. So for example, if I move these to here, there will be a line of points, or any other configuration just doesn't work. So this is the only configuration, something like this. Now to find this point, I need to do a few things. First, for each of these diamond shapes, I need to figure out the x and y value. So something like this or like this. So if we look closer, we will see that all these lines have all the ones that are like positive have the equation, which is y is equals to x plus some c, and the c is and when the c changes, this line will go up or down. So like here, this is y equals x, and then if we like move this uh, a units to the top, then this line will be y equals x plus a. So, and we should consider that all these lines are parallel. So these red ones are all parallel to each other. And the only thing that is different between them is this c value, which is changing. And for the other lines, so like for example for these ones, no, not green. So let me say, I don't know, maybe blue. So for these lines, our equation is minus x plus some constant, and this is changing, and this is the same here, so this will go like this. Right. So if I say that I have one of these diamond shapes, and I think this is the center point, which is A and B. If I have a positive line like this that goes through this line, it will be y equals x plus b minus a. Simple algebra. We have c here. We will substitute b and a for y and x. So it will be like this. Because this line is passing through this point, we could include this in the equation. So it will be b equals x, not x, a plus some c, and the c will be b minus a. So the equation will change to this. This is for positive lines, and we know that the distance from here to here is like what? Yes, exactly. This distance is d. So this line, which is this line moved like d to bottom, will be y equals x plus b minus a minus d. And similarly for this one, it will be y equals x plus b minus a, but this time plus d, because we are moving d to the top. And for those that are on the let's say negative, let's say them they are blue. So for these ones we can similarly say that these are x minus x plus b minus a minus d and plus d. So I have these like equations for lines, and based on these ones I can find the single point that is, outside of all these lines. So I will check all of these, let's say, negative lines, and by checking through all of them I will find a single point that is like for example, if I have another line here, the distance is 1 between these two, and then there will be some positive ones, um, some positive ones like this one, which have the distance 1 between them two. So this point will be the point that we are looking for it. Alright, I hope this is clear. Let's get to the code. So for part 2, the getting the data and everything is the same, the for loop and everything is the same to get the distances and so forth and so on. But later on we don't need to have the const y value, because we are not checking against a single line. We need to have the positive lines and negative lines, and we go through all the sensors, and using the equation that I just described, I will get all the positive lines and all the negative lines by doing this and this. Then I need to find the positive and negative, which goes through this double for loop for all the sensors. In this line and in this line I will find the positive and negative, that is the value that we want. Then I will divide that x by 2 and y by 2, and then our answer is something like this, which is provided here in this here. We should multiply by 4 million and then add y to it, and then we can get to the result. So this was pretty much it. The code is always on the GitHub, so you can go and check. So hope to see you soon. Take care, and see you tomorrow with another puzzle of Advent of Code 2022.